This is the quadratic equation. This is our quadratic equation. This is the formula for the quadratic equation. And this is on the reference sheet. And what I want you to do today is to do some investigation, is to use the quadratic formula. I know you can factorize this, but you have to use the quadratic formula to find the roots or the answers to the quadratic equations. And write down whether the roots are rational, irrational, equal, unequal. We'll talk about that later on, but I just want you to use the quadratic formula. So for example, this one you do x is -5 plus or minus. Make sure you show all the steps. Minus 4ac, right? Now don't do the whole thing on a calculator, because I want you to see as well what's inside the square root. So can you please work out what's inside the square root? Do not just type everything on a calculator, okay? Because we want to see how the formula works. That's the main idea. So go 5 squared minus 4 times 1 times -6, and you should get the answer 949. And then you can do on a calculator. So that means you will get, so you can now type in -5 plus, so I want to do it in slow motion so that we can see what's going on. 1, okay, so you get 1, and the other one, you will get negative, you get -6, okay, cool. All right, can you please do the B, do the same thing, C, and then D. All right, have a try. Give me about 5 minutes. Go. All right, let's record. Let's try this. Equal to 6. That would be 8. Well, hopefully up to the last one, so you get 9 minus 80. And what's that? That's -71. Okay, good. So you say no solution. Okay, good. So what we do is we sort this, and hopefully you're done. So you got these. Let's make it a bit smaller. Okay, so you got 4 cases. And each of these cases, you can sort of tell what type of solution you will be before you get to the last step. So you will see that, hopefully you will see that when that's a 0, plus and minus 0 is the same thing. You only get one answer, one solution, right? And when it is negative, there's no solution. And then when it is positive, there are 2 solutions. Does that make sense? Okay, so because it discriminates between these 3 cases, no solution, 1 solution, 2 solutions, we'll call this thing the discriminant. Okay, so discriminate between these 3 cases. No solution, 1 solution, or 2 solutions. So instead of applying the whole quadratic formula, I just have to calculate what's inside the square root. So this is summarized on the next page. So if you look at the next page, if you have a highlighter, let's highlight this. So basically, the thing we just talked about are called the discriminant, So again, I'll highlight this, right? So basically the thing we spoke about is the discriminant, which is b squared minus 4ac, and the symbol for discriminant is called delta. And when delta is bigger than 0, there are 2 real roots. When delta is discriminant 0, there's 1 real root. Or discriminant less than 0, there's no real root. Okay? Okay. So this is the discriminant. It discriminates between 3 different cases. Alright, you have to remember that. So particularly when discriminant is 0, it doesn't mean no root, it's 1 root. Does it make sense? 0 means 1 root. And to remember that is to remember this example, because when that's 0, you get 1 answer, right? Okay, when it's positive, you get 2 different answers. When it's negative, you get no answers. Okay, any question? Discriminant? Okay, now we haven't spoke about the last thing. We have to talk about these ones. What do they refer to? Okay. Okay, let's look at this. So if you look at more closely, the discriminant, if it's positive, is 2 solutions. And in fact, we can get into in a deeper level. If this is a perfect square, okay, see 49 is a perfect square, means if you can square root the perfect square, you'll get rational, as in fractions or integers. So that indicates to you, if it's a perfect square, you can factorize this. You're allowed to factorize. If it's not a perfect square, then you get irrational. You get surds. So that's how we know whether the solutions are rational or not, or something can be factorized by just looking at the discriminant. So if you can't factorize something, that means the discriminant is not a perfect square. So if it's a perfect square, you can factorize it. Does that make sense? Okay, so now we can see irrational, rational. Okay, any other questions? Okay, another thing we need to talk about is equal or unequal. What does it mean? So when the discriminant is positive, we say there are 2 unequal roots or 2 distinct roots. They are different, or 2 unequal roots. Okay, yeah, because we talk about different things. So when it's positive, it's 2 distinct roots. Whereas when you get 1 solution, we can think of actually 2 solutions, but 2 equal roots. There's 2 answers, but they're just equal to each other. Right? So that's what they mean when they have equal or unequal roots. Okay? And why is it 2 equal roots? If you actually factorize it, let's say we try to factorize, we get x minus 3 all squared. It's a perfect square. And using the null factor law, you see there's 2 brackets, x equal to 3 or 3. See, they're equal to 2 3's, right? So whenever you get a perfect square, if the quadratic expression of a perfect square, the discriminant will be 0. Does that make sense? So if it's discriminant 0, you get a perfect square. Perfect square. So you can get a lot of things out of the discriminant. Or you can say the roots are 2 equal roots. And of course, when it's negative, there's nothing to talk about. There's no roots, right? Okay, good. You can still say unequal, but if you look at extension 2, you will say, the people who's doing extension 2 now will talk about complex numbers. So you have 2 unequal complex roots. But you don't need to know that. That's for extension 2 students. Extension 2, okay? But for tuner level, you just say no solution or no real roots. Okay? No real solutions. There are solutions, but they are called complex solutions. But you don't need to know that. Okay, all right, so let's go to the next page. So you say, yeah, discriminant positive, 2 unequal roots or 2 distinct roots. It's written here. If the discriminant is 0, we say it's 1 root or 2 equal roots. These terms can be used interchangeably. If the discriminant is less than 0, we say no real root or 2 unequal or two unreal roots, okay, or two complex roots. Okay, now let's apply discriminant again on this problem. For each of the following, use the discriminant and use it to check the number of solutions. So let's find the discriminant, b squared minus 4ac, which is 4 squared minus 4 times 1 times negative 14. If you use your calculator, what would you get? 72? Okay, correct. Now what does it tell you? So what does 2 real roots? Well done. And more specifically, it has 2 irrational roots because it's not a perfect square. So that means you can't factorize this quadratic. You can't factorize it because you get surds. Yeah? Alright, try the next one. Find the discriminant of each and write some amazing conclusion. Okay, do that now. Yeah, let's go through the questions. So you need to do the question. Right, use the calculator, but you still have to write down the discriminant and then write a conclusion. Okay, do that now. If you want, yeah, if it's perfect square. But you don't have to. You just say how many solutions. But you can tell from the discriminant whether it's rational or irrational. Okay, all right. Let's do the next one. Negative a squared minus 4ac. What do you get? 64 minus 40. 24. Again, 2 real roots. How about the next one? That will be 0. So, and then write a conclusion. Alright, Nat, discriminant is 0. How many solutions? Excellent. 1 real root. Or in other words, you can say 2 equal roots. Okay? Note the term, because in the exam they will use this term. They say 2 equal roots. It means discriminant 0. It means 1 root. Okay? And lastly, you do this. Negative 4 squared minus 4ac. Does it give you 24? So that's negative 8, right? So we say no real roots. Or just no roots. Easy enough. Okay? Alright, after we do this, now we know how discriminant works because it discriminates between these 3 different cases. Now we can do an exam type question. Okay, so now we can look at this quadratic equation. Now notice that this quadratic equation has an extra polynomial. And we're going to find the value of n so that it has 2 equal roots. Should have an s there, sorry. 2 equal roots. Okay, so how does it work? Now go back to the discriminant. 2 equal roots means discriminant is 0. Let's find the discriminant. It's b squared minus 4a, and your c is this. That's your c. That's your a, that's your b, right? 4ac, which is n, equal to 0. So it's a very easy question. So you just have to look at 2 equal roots, write down what the discriminant is, and solve the equation. And that one's easy to solve. 4 minus 4n is 0. That means n must be 1. So when n is 1, you have 2 equal roots. Now, can we actually check whether it works? You don't have to check it. We can check it now. Let's put 1 in there. Does it have 1 root or 2 roots? If we solve it, it's a perfect square. As expected, you have 1 root only. 1 root. As expected. Does that make sense? Right? Because you say when n is 1, you get 1 root. When discriminant is 0, right? Discriminant 0, 1 root. So when n is 1, you get 1 root. Yep. or 2 equal roots, right? If you look at the perfect square, there's 2 brackets. So 2 equal roots. Because you can go x plus 1, x plus 1, right? But they're just equal to each other. Yeah. Yeah. Okay, any question? Let's try the next one. N is not the number of solution. N is the number. If you find that number, so you have to find what n has to be so that the quadratic has 1 root. And the quadratic has 1 root, that's when discriminant is 0. And with this discriminant to work out what n value you have to be so that the equation has 1 root. It's just that it's coincident that n is 1 corresponds to 1 root, but doesn't always correspond that way. Okay, real roots. What does real roots mean? Real roots could be 1 root or 2 roots. So in that case, you have to do the discriminant bigger than or equal to 0. Okay? So you do the same thing. So you just can copy and paste this, 4 minus 4n, but this time it's an inequality. So solve bigger than or equal to 0. Negative 4n is bigger than or equal to negative 4. N is less than or equal to 1. So when it's less than or equal to 1, you have 1 root or 2 roots. Of course, 1 root is when n is 1. Anything less than 1 will have 2 roots. Yeah? Okay, so we'll solve some harder questions. Then we'll look at even harder questions using the same concept. Okay? All right, go to the next page. Got 2 more pages to go. Then we're done. All right, okay. Next page. All right. Find the value of m. Again, we're finding a value so that this has 1, 0. So notice that these are the terms you need to know. Root, solution, 0, they all mean the same thing. It means the answer to a quadratic or answer to any equations. So remember these 3 words, they can be used interchangeably. Root, solution, 0. So 1, 0 means 1 solution. Okay? So what will be the value of the discriminant? Discriminant will be 0. Okay? So you find the discriminant. B squared minus 4ac equal to 0. B squared minus 4ac equal to 0. Right? Does that make sense? So now you don't have to expand this because it's a perfect square. You can just move the 16 on the other side. Right? And then what do you do? What do you do? Square root it, plus or minus 4. So m must be 6 or negative 2. Yes? Good. So when m is 6 or negative 2, you have 1, 0. Okay? We can test this out. Let's test this out so you can see how it works. Let's check it. Let's check. So that's when m is 6, what do you get? You get x squared plus 6 minus 2, x plus 4 is 0. Like that. And you get perfect square. Whenever the discriminant is 0, you get perfect square. So what's x equal to? Negative 2. 1 root, right? Does that make sense? M equal to negative 2. You get x squared plus negative 2 minus 2. You also get perfect square. Right? You get x minus 2 is 0. So therefore x equal to 2. 1 root. Say again? Well, when m is 6, it's important not to get confused with what m is and what the solution is. M is 6 will cause this equation have 1 root. M is not a root. M is the value you have to find so that this equation has one root. Does that make sense? So this equation here, if I have different value m, the equation will have different number of roots. But if I choose m to be 6, you will have one root, as you see here. So if I put 6 into the equation, I get one answer. If I put -2 into the equation, I also get one answer. Yeah, but if I choose a different value, I will get 2 answers, or I may get no answers. Yeah. Yes. Well, So basically, before, see, you got n to be 1. Sometimes you get one answer. So only when n is 1, you get one answer. But sometimes you could have 2 different values of m, depending on the complexity of the equation. Yeah. So it can get confusing, but you need to know what refers to what. So this m value here is the value you have to put into the equation so that the equation has one root. Yep. Okay, does that make sense? So, but you don't have to do the checking. This is not required. Not required. Okay, any question? All right, okay, after we do this, we're going to do the next one. All right, let's continue. All right, so if you're done, how about the next one? Two distinct solutions. What's the discriminant going to be? Greater than 0. Okay, so you go discriminant greater than 0, but we've already calculated the discriminant. What's the discriminant? The discriminant is this object. Now, we need to solve this quadratic inequality. How do we solve a quadratic inequality? We have to draw the graph. Does that make sense? And what's the x-intercept of the graph? Have we found it already? We have 6 and -2. That's when discriminant 0, right? 6 and -2. And you draw a concave up parabola. And then which part do we look at? Bigger than 0, above the x-axis, or in fact horizontal axis. So in that case, m has to be more than 6, or m has to be less than -2. Any question? So once you do the first part, the next part is just very easy, because you got most of the information you need. Yep. I solved the equation there. It's a perfect square. I square root it, and then I got 6 and -2. Okay, last bit. No real roots. What's the discriminant going to be? Less than 0. But it's the same inequality, isn't it? Except it's less than. And it's also the same graph. Same graph. I can just copy it. But this time we look at a different part of the graph. Which part do we look at? The bottom. So therefore, m has to be between 6 and -2. So it's very easy, isn't it? So you only have to look at the information about the roots, use the discriminant, and then you either solve the equation or solve the inequality. If it's an inequality, draw a parabola, if it's a parabola. Okay? Whereas the one before, it's not a quadratic inequality. We'll just solve it directly, right? This one we just solve. We don't need to draw because it's not quadratic, but this one is quadratic. Yeah? Okay. Hopefully you have a very good idea now. And you should be able to do the homework from the textbook, but we've got one more page to go. We've got a harder question to go through. Then you can start 9.3 today. Is that related to this? 9.2, how to solve quadratic inequality. Only this is related. Alright. Okay, good. We've got one more page to go through. Alright. Yes, one more page. No, I say 4 pages at the beginning. I said page 7, 8, 9, up to 10. Alright, let's continue. Show that this equation has real solution for all values of k. What does it mean? Well, to do that, the first step is to find the discriminant for AC, right? Discriminant first, A, B, C, okay? A, C, that's B, alright? Alright, any question? And then I want you to simplify it first. So let's simplify. You get k squared minus 6k plus 9 plus 4k. Like that. And if we collect like terms, you get negative 2k. Like that. 6. B and 6. Okay, let's continue. Now, you have to show that it doesn't matter what k is, you always have real solutions. Now, how do we show that? We have to show that this thing is always positive. We have to show that. Show it is always positive. Now, how do I show something is always positive? Is to complete the square. Now, if we complete the square, we can break the 9 down into 1 plus 8. Right? 9 is 1 plus. Why do I break it down into 1 plus 8? Because this thing is a perfect square. And why is perfect square so special? Other than it's being perfect, it has wonderful property. And the property you want to make use of is the fact that the perfect square is always positive. Right? Because if you square something, it's always positive. And 8 is definitely positive. So what does it tell you? It tells you that it has to be positive for any values of x, of k. And why is this special? If it's positive for any value of k, means that the discriminant is always positive for all k. And if the discriminant is positive for all k, that tells you that the quadratic equation always have real roots. Has real roots, real solutions for all values of k. This is a little bit hard. I would say this is a bit more challenging. But note the wording and note how I do it. It's a question that they could ask you in the next coming exam. Alright. So basically, if I substitute any number of k there, I'll always get solutions. This quadratic always has solutions. It doesn't matter what k I substitute in here. Because if you look at the discriminant, it's always positive. Yeah? Alright, good. I think we're done. Then if you have more questions,